In my last video, I did Euclid 2020 question 8. Today I'm going to do Euclid question 9. If you like my video, make sure to subscribe to my channel.
Let's get into the question now. So question 9 is an L shape is made by adjoining three congruent squares. The L is subdivided into four smaller L shapes as shown. Each of the resulting L is subdivided in the same way. After the third round of subdivision, how many L's of the smallest size are there? And part B is after the third round of subdivision, how many L's of the smallest size are in the same orientation as the original L? And part C is starting with the original L shape. 2020 rounds after subdivisions are made. Determine the number of L's of the smallest size that are in the same orientation as the original L. So part A is quite easy. We know that each L will be subdivided into four smaller L shapes. So then there will be 4 times 4 times 4, which is 64 smaller L shapes in a large L shape. For part B, let's draw this diagram. So in this diagram, if we start with an L shape on the left side, we'll end up with a 4 L shape on the right. And using this previous diagram, we could create a table that will represent how many small L shapes are there in the largest L shape. Since we're looking for the L shape that are in the same orientation as the original L after the third round, so we'll have our answer, which is 20. Let's get into part C now. So recall the last chart, but instead of filling out with actual values, let's put in these variables. So in this problem, we will be just finding A 2020, and that will be our answer. So let's look back into the L-shaped diagram. If we have one L shape that is without the top right square, we'll end up with two L shape that is without the top right square, and one without the top left square, and one without the bottom right square. So then we could conclude that an plus 1 equals to 2 times an plus bn plus cn. And using the same method, we will be having bn plus 1 equals to 2bn plus an plus dn, and cn plus 1 equals to 2cn plus an plus dn, and dn plus 1 equals to 2dn plus bn plus cn. Since we have b0 equals to c0 and bn plus 1 equals to 2bn plus an plus dn, and cn plus 1 equals to 2cn plus an plus dn, and we will have for all integers n, bn equals to cn. So then we could have an plus 1 equals to 2an plus bn plus cn, which equals to 2an plus 2bn. And also we will have bn plus 1 equals to 2bn plus an plus dn, which equals to an plus bn plus cn plus dn. And an plus bn plus cn plus dn would be just the number of small L shape in the large L shape after the nth round. So then we'll have an plus bn plus cn plus dn equals to 4 to the nth power. So then we could know that bn plus 1 equals to 4 to the nth power, and so bn equals to 4 to the n minus 1th power. So after that, we could know that an plus 1 equals to 2 times an plus 2 times bn, which equals to 2an plus 2 times 4 to the n minus 1th power. So by that, we'll have an plus 1 equals to 2an plus 2 times 4 to the n minus 1th power. And that equals to 4 times an minus 1 plus 2 times 4 to the n minus 1th power plus 2 times 2 times 4 to the n minus 2th power, and yada yada yada. In the end, we'll have an plus 1 equals to 2 to the nth power times a1 plus 2 to the 2n minus 1th power plus 2 to the 2n minus 2th power plus 2 to the 2n minus 3's power plus yada 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 plus 2 to the n's power. Since we know that a1 equals to 2, so then we'll have an plus 1 equals to 2 to the 2n minus 1's power plus 2 to the 2n minus 2's power plus 2 to the 2n minus 3's power plus yada 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 plus 2 to the 2n plus 1's power plus 2 to the 2n plus 1's power plus 2 to the n's power. And that equals to 2 to the 2n's power plus 2 to the n's power. Now we can know that A2020 equals to A2019 plus 1. That equals to 2 to the 4038's power plus 2 to the 2019's power. And there we have our answer.
In order to solve question 9, you need to know how to count recursively. Hope you enjoyed this video. Make sure to subscribe my channel.